All right, let's talk about chapter 18. This will be the last chapter for the semester. And this particular chapter focuses on the human impacts on the ocean. So as you can see in this image here, there's a lot of trash. So that's just one particular example of a human impact that we have on the ocean. But we'll talk about a few more in a sec. Okay, so what are human impacts? And scientists have termed human impacts as anthropogenic impacts, right? And anthropogenic effects. So any human activity that has a negative impact on the environment is known as an anthropogenic effect. And so in this image here, you can see that, we have houses, we have apartment buildings, we have sewage treatment plants, we have cars and, farming and our landfills and our industries. And all of that has somewhat of an impact on our environment. So our landfills have an impact because when it storms, all of that trash can get into the ocean, or it can pollute the land. Industries emit combustion vapors, I guess you could say, into the air, which then get into the atmosphere, which then get precipitated out over the ocean. Sewage treatment, when it storms really badly, sewage can get into the ocean via runoff, just general trash, your CO2 emitted from your cars and your machines. All of that gets into the ocean at one point in time, and they all have a negative effect on the environment. So let's look at what it means what that environment component means, because essentially if we are negatively impacting our environment, that means we're affecting all of those organisms that live within that environment. So here are just some different habitats or where organisms live at. And you can see here the polar bears are affected greatly by global warming. You've got that, what is it there? An elephant in the jungle, and that elephant there is being affected as well too. Even to the smallest insect, like that scorpion there. Every habitat on the earth, it doesn't matter where it's at or how unformidable it is affected in one way or another by our actions, what we do on land and how it ends up in the ocean, all right? Because remember, whatever we do to the atmosphere also affects the ocean. So it's not like, oh, well, we're on land, we're not in the ocean. It doesn't affect the organisms in the ocean. No, that's, as we know, when you drive around in your car, you're releasing CO2. That CO2 gets into the ocean, which then acidifies the ocean and makes it harder for coral reefs to live. So that's just one example. So what sort of impacts do we have on the coral reefs? We have eutrophication, which is just the excess nutrients in the water, leading to rapid algae growth. And this rapid algae growth outcompetes the corals. So that's the reason why this excess of nutrients in the water is really bad. You can have ocean acidification, where the water becomes more acidic. And for corals in particular, they need a basic condition. They need that pH to be 8 or higher in order to perform their calcium carbonate processes, in order to deposit calcium carbonate into their skeleton. So if they don't have that basic solution, then they have a harder time growing and therefore surviving. You can have coral bleaching. So coral bleaching is when the water temperatures become too high for corals, and their zooxanthellae, which are their symbiotic dinoflagellates, are expelled out of their skin. So they no longer have that access to that resource that they had when the zooxanthellae were in their skin. And then trawling. Trawling scours the ocean bottom for fish and shrimp. And when you trawl, that large net basically just scoops up whatever's at the bottom of the ocean. And if it's a coral, then it will either completely destroy the skeletal structure or it will damage it pretty significantly. All right, so let's look. Here are some images of the 4 things that I showed on the last slide. The top left-hand image there is that of a coral bleaching event. You can see the coral in the foreground is white. It looks like it's been bleached. And that coral there has lost its zooxanthellae because of the warmer temperatures. You can see the coral in the background that's kind of a brownish color. That's a live coral. You can see all the fish hanging out around it. You can see all the fish that, there's only a few fish surrounding that bleached coral. So you can tell it really damages not only the coral, but also the biodiversity on the coral reef. All right, the bottom left-hand image is that of eutrophication, and that is an overgrowth of algae in a pond. And because of that overgrowth, the algae used up all of the oxygen within the water and caused that fish there to suffocate and die. So that's one problem. Another problem is it blocks out all the sunlight, so the sunlight doesn't reach deeper depths in that water because it's being blocked out. So normally it would be able to go a pretty decent distance, but if there's too much algae, then it'll block out the sunlight too. So anything growing below it, so like say this was in the ocean, if there were coral growing below this, the coral would die out because there would be no sunlight. The top right-hand image is that of trawling. So you can see that huge net is being dragged along the bottom of the ocean. And it's just whatever's on the ocean is going to get caught into the net. It's going to get broken. You can see there's a lot of sediment being picked up by this trawl. So it's kind of really just devastating. Yeah. You can kind of equate it to, like, say when you go out and mow the lawn, you're basically giving the ocean floor a buzz cut, right? Which is not very good for the coral reefs. And then the bottom right-hand image is that of ocean acidification. So you can see this one calcium carbonate shell. And that shell, in that image, the top left image of that shell is that of a shell in normal pH, so 8.1. But as you go to the right in the top row, and then you come back to the bottom row, and you go from left to right, you can see that shell is starting to take on a different shape, right? So you can see in that top row there, you start decreasing the pH, and each time you decrease the pH, that shell becomes a little bit more opaque. It's starting to become a little bit more brittle until you get to the very end where it's a very, very acidic in the bottom right-hand corner there. And that shell is almost non-existent, right? And pieces of it are missing. So this is what ocean acidification does. It doesn't allow for the deposition or the depositing of calcium carbonate in skeletal structures. So that's some effects that it has on coral reefs. Now, pollution is any harmful substance that has a negative impact on the environment. So types of pollution would be eutrophication, sewage, oil spills, toxic substances that get into the ocean, solid waste, which is like your trash or your garbage, and thermal pollution. So this is hot water. Okay, so as we mentioned a little bit in the effects that coral reefs have, eutrophication not only affects coral reefs, but it also causes anoxic and hypoxic conditions. So anoxic, so the A is just Latin for none. So anoxic would mean no oxygen conditions. So that's a situation where the algae has used up all of the oxygen in the water. And then hypoxic is just conditions where you have little oxygen, right? And so in this case, you have very minimal levels of oxygen. It may or may not be enough to sustain life. And in most cases, if it's too little bit, then organisms like that fish in that image will start to die off, right? And as you can see in this image, it creates plankton blooms or algae blooms. And these algae blooms happen really fast because the algae and the plankton will reproduce really quickly because they have an excess of nutrients. And typically speaking, you'll see this type of conditions occurring when you have stormwater runoff and sewage spills. I don't know if you remember from the coral reef discussion, sewage being introduced into the water is highly nutritious for algae. All right, now sewage sludge. Oh yeah, here we go. So sewage sludge is a type of chemical pollution into the ocean because it's introducing nutrients into the ocean, right? I mean, aside from the fact that you may have an occasional floater here and there, it's really just the fact that it introduces an excess of nutrients into the ocean. And sewage, I believe we talked about this, so forgive me if I'm going over things in duplicate, but sewage is treated in 3 different stages. You have your primary, your secondary, and your tertiary treatment. So your primary removes your solids. Your secondary removes the solids, so everything in primary, plus it gets rid of some of the bacteria found within sewage. And then tertiary does what secondary and primary does, but it takes it a step further and filters and treats the sewage. With anything, excess nutrients in the ocean will lead to an overgrowth of algae. Petroleum is another type of pollution that you can find in the ocean. Pollution is naturally occurring, and when petroleum gets into the water, it can cause it can kill marine organisms because of the toxins that are found within petroleum. So some of the toxins that you'll find within petroleum are PAHs, which are polyaromatic hydrocarbons, and like heavy metals and stuff. So when you have oil spills, for example, the image that is shown here is that pelican in the water. Its body and feathers are completely covered in oil. So those feathers are special feathers because they have oils on the feathers to help repel the water and keep the bird warm, so that the water doesn't touch its skin and steal the warmth from the bird. But with that oil covering the feathers, it lets the water seep all the way down to its skin. So if that bird stays in the water for too long, it will suffer from hypothermia and eventually die. Also, all of the extra oil on top of those feathers are making it so that that pelican cannot fly away. So it can't get out of that situation that it's in. And then most likely that bird has probably ingested huge amounts of that oil. And because of the toxins found in that oil, it probably will be poisoned. So hopefully it didn't ingest too much of it. But any sort of degreaser like Dawn has been used to try to help these marine birds in these types of situations. So cleaning up oil spills can be kind of tricky because oil does naturally degrade over time in the ocean. But initially when an oil spill occurs, oil floats, obviously, because it's less dense than water. And when it's floating at the surface, it's not too bad to clean up. It just depends on where the location of the spill occurs. So for instance, if it's in an area where there's a lot of wind and waves, that could make cleanup a little bit harder. But if it's in an area that's not too bad, maybe it's a little bit calmer, then they have things like vacuums that will suck up the oil and dispose of it properly. But if it takes a while for rescuers to go to the location of the oil spill to clean it up, eventually the sun will separate the oil as it degrades, and it will separate it into its different components. So for instance, crude oil, which is what you see in the image right here on the beach, when it degrades, it breaks up into a number of different products. But the three main ones would be diesel, which is the heaviest. Then it breaks down into gasoline, like car gasoline, so the gas that you put in your car, which is a little bit lighter than diesel. And then you have jet fuel. So those are the three different types of materials that you can get from crude oil. And when it separates into these different layers when it degrades. Now, bioremediation is just the use of microbes or bacteria to clean up the spills. So these microbes are special microbes because they eat oil basically. And the only problem with using these microbes is that they need conditions that are right. You can't throw these guys into the ocean on a really windy and wavy day. It's not going to help the situation at all. And it's a slow process. So it doesn't happen right away. So sometimes there's not enough microbes within whatever oil spill. If you threw a bunch of microbes, there may not be a lot of them to clean up the entire oil spill. So while it's a more natural way of cleaning up oil spills, it's not the most effective way. The most effective way still yet would be this next slide here, which is to prevent oil spills in the first place. And if we could do that, then there would be no need for cleaning up or protecting marine organisms because all the oil would just stay in its container. But unfortunately, there have been a number of incidences over the past few decades, and I know one in particular was Exxon Valdez up by Alaska, and that was a tanker that ran aground and lost all of its contents, the oil that it had in its hull, and so it caused, and up there in Alaska they have a lot of wind and a lot of waves, so it made cleanup really hard and very difficult. One way that you could try to prevent spills is by producing tankers or ships that are double hulled. So meaning they have two hulls, an inner hull and an outer hull, much like your house where it has insulation. So it has an outer wall and an inner wall. And those walls, that outer wall is meant to protect the inner wall. So if something happened to the outer wall, the inner wall will still be intact and it will still hold the oil inside of the hull of the boat. So that's the idea. But as you can see in this image right here, this is a pretty significant breach of the hull in this ship. It's hard to tell if this ship broke through the double hull or if it was just the outer hull that it broke through. But nonetheless, this is pretty significant, and if there was an oil spill from this boat, it would have released a ton of oil. Alright, the next type of pollution you can have in the ocean are PCBs and DDT. So these are chemical pollution that you can get in the ocean. PCBs is a liquid chemical that is used in transformers. So whenever you transform electricity from one voltage to another, you need something to cool it down. So on those high voltage power lines, you'll see these white boxes, and these white boxes are meant to take the voltage from the power lines and convert it down to a lower voltage so that when you plug in your TV or your computer or your phone in your house, it doesn't explode, but it charges it, right? So, but when you convert energy like that, it heats up. So it heats up the machinery that's used to convert that electricity down. So you need something to keep those machineries cool. And back in the day, they developed this chemical known as PCBs. And this chemical is quite amazing at its job. It keeps those transformers pretty cool comparatively, but it is highly toxic for the environment. It causes cancer and whole slew of like birth defects and a bunch of stuff you can think of in humans. And if humans were to eat those organisms like the fish, when it gets into it, it's not good. And then DDT was a pesticide used back in the day. And while it didn't have a direct effect on the environment, I mean, it did in the sense that it was very effective at killing insects, like nuisance insects. But it also had a side effect where it caused a weakening of the shells from birds. So from eggshells from the birds. So birds would lay the eggs, and birds naturally will then sit on their eggs to keep them warm. But birds that were affected by DDT, they physically themselves were not affected by it, but their eggs were. So as you can see in that image there, those eggs became very brittle and very weak. And so when the mother would go and sit on her eggs, she would crush them, and she would then end up killing her babies, which weren't exactly babies at the time, but essentially it caused a decrease in the bird population at that time. And these particular chemicals are very damaging to the environment because they linger for many years. So it takes them probably decades to come out of, like I know DDT, it took, I think, 10 to 20 years before all of the DDT disappeared from the environment. And then the bird population also came back. But PCBs never degrades. It never leaves the environment. It just stays there, and it continues to wreak havoc on the environment. So that's the reason why chemical pollution is so pervasive and such a such a problem. Another type of pollution in the ocean is mercury. Mercury is released into the atmosphere or the environment when you burn fossil fuels, so oil and petroleum. And when elemental mercury gets into the ocean, bacteria converts it into methyl mercury, which then is absorbed by the plankton, and the plankton are then eaten by the fish, and then humans eat the fish, and we become poisoned by the mercury. As mercury travels up the food chain, it bioaccumulates in the larger fish. So that means that there's higher concentrations of mercury within the larger fish than there are within plankton. And I'll show you a graphic of that in a little bit. But humans, when they eat a lot of fish and accumulate enough mercury within their body, they suffer from some serious health issues like birth defects, brain damage, paralysis, death, and blindness. So a very famous case of mercury poisoning is in Japan, in a place called Minamata. And over there, they had a chemical plant that was releasing mercury into the bay. And they didn't know the effects of mercury at the time, but the village that lived right on the bay, they would regularly go out into the bay, fish, and bring back the seafood and actually eat it on a regular basis. But once they started to see that people were starting to become very sick, they would give birth to babies that had a lot of health problems. A lot of times the babies would be stillborn, just a whole slew of problems. And they figured out that it was coming from this chemical plant that was nearby that was releasing all of its waste into the bay. So, needless to say, after they stopped doing that, things eventually went back to normal. All right, so on this slide right here is one of those small little handy dandy cheat size wallet cards that tells you which marine organisms are safe to eat and which ones you should limit the amount of fish you should eat. And everything within that low category there has very low levels of mercury. Typically, there is no limit on the amount of quantities that you can eat from this category. The only thing to keep in mind about this is the organisms that have a red asterisk at the end of it. Those are the ones that are overfished in the wild. So, for instance, in that low category, you can see that flounder has a red asterisk. Well, that means that in the wild, flounder is overfished, and you shouldn't be purchasing this. But all of the flounder that you see in the supermarkets now, those are farm raised, so those are okay. That is a sustainable fishery. Same thing with shrimp. All the shrimp that you get in the market is not wild caught. It's all farm raised. So if you were to try to get some wild caught shrimp, that would be pretty expensive. Moving on to the medium category, these particular fishes you should probably not eat. You should probably not eat these types of fish more than a couple times a week at most. And then when you get to the high category, you should definitely limit the amount of fish that you eat from this category to maybe like once a month, probably. You can see a lot of the fish in this category are overfished. You can see almost all of the tuna species are overfished. You can see swordfish, shark, sea bass, marlin, grouper. All of these are in the wild overfished. I believe, well, actually, no, I have no idea. I don't think these particular species, I don't think they've developed a way of farm raising these ones. But essentially, you should try to avoid eating these ones, not only for the fact that they are overfished, but because they have a higher mercury concentration. But keep in mind, mercury concentration is relative because a lot of these fish have very high concentrations of selenium. Selenium has been shown in research to counteract mercury within fish. So even though you may eat a lot of fish, you may not readily experience health problems like the people in Minamata. The people in Minamata, the mercury concentrations was 10 times higher than those in the high category. So just to give you a perspective of how much mercury they were eating, it was more than the average person would normally get on a regular basis. So yeah. Next, bioaccumulation and biomagnification. So bioaccumulation just means that as an organism becomes bigger and larger, it's going to accumulate more mercury or more toxin within it. Biomagnification just means that as you go up the trophic level, so when you go from your krill all the way up to your shark or your tuna, your shark and tuna is going to have several times more concentration of mercury than the krill, partially because of its size, partially because of the type of organisms that it's eating. In the image on the right, you can see that as the krill is eaten by the salmon, that salmon is accumulating mercury, but not enough to be harmful to humans if they were to eat the salmon. And then you see the tuna, which is then eating the salmon, and it's getting a little bit more mercury as indicated by the thermometer at the bottom. And so these particular ones you wouldn't want to be eating too often. And then you can see the larger halibuts and the sharks. They're eating the smaller tunas, and they are accumulating more mercury to the point where it's probably not advisable to eat these very often. So that's a demonstration of bioaccumulation. Biomagnification is displayed in the image on the right hand side there, and as you can see at the bottom, those microscopic algae don't have a lot of mercury within them. They have 2 dots. All right. But then when you get up to the heterotrophic bacteria that are eating the algae, it doubles. So now they have 4 dots. And then you go up one more level to the small fish that are eating the plankton. They have 6 dots. At this point, it's not too bad. It's still safe to eat those small fish. But then once you get up to the larger fish that's eating the smaller fish, then it doubles again. Well, not doubles. It adds 2 more dots. So now you have 8 dots in there. And then you get up to that bald eagle. That bald eagle that's eating that large fish there, now it has, let's see, 2, 4, 6, 8, 10, 12. 12 dots. So that it jumped up quite a bit. So from the microscopic algae that only had 2 dots to the eagle that has 12 dots, it's magnifying. The mercury concentration has magnified by 6 times. The next type of pollution that you can find in the ocean, and probably is the majority of the pollution in the ocean right now, is plastics. Plastics aggregate at the surface because they float. Not all of them float. As you can see in the example on the image on the left-hand side there, plastic bags do float, but sometimes they'll float in the middle of the water column, and so they will look like a jellyfish to that turtle there. So that turtle will ingest that plastic bag but get no nutritional value from that plastic bag. But a little less than 80% of the marine pollution is land-based, and it is plastic, so that's quite a bit. Majority of the plastic in the ocean does not readily degrade because it's not that biodegradable stuff. And even that biodegradable stuff takes a while to degrade. So even though they try to market that as the safer alternative to plastic, really just reusing and washing your containers is the best solution in this case. This plastic in the ocean can strangle and kill marine organisms. I have not put any really terrible photos in here, but if you do Google, if you so choose, you can Google how plastics affect marine organisms, and some pretty graphic photos will come up. But the most graphic photo I have is of that turtle down in the bottom right hand image there. It is slowly being strangled by that net, and it's totally entangled by it. So if that turtle can't get free from it, yeah, it will eventually die. But fun fact, it is illegal to dump plastic in the ocean. So how does all of that plastic get into the ocean? We'll talk about that in a little bit. But majority of the plastic that gets into the ocean is primarily from runoff. All right, so when we have a big, large storm or we have some wind, picks up that plastic, it gets into the ocean, and it starts to break down, and eventually you'll get what's known as microplastics. Microplastics are small plastics that are less than 5 millimeters in diameter, so they're small. That happens when the sun degrades them and breaks them down. You can also find microplastics in cleaners and scrubbers and toothpaste. Technically speaking, they should have banned those microplastics in the face scrubbers. But if you guys used to use like Biore facial wash, that orange one with the blue beads in it, which is an example in the bottom right-hand image there. Those blue beads were plastic, and even though it was great for exfoliating your skin and cleaning out all of the dirt and whatnot in your pores, they did create an environmental hazard, because what ends up happening is these microplastics, because they're so colorful, you can see an example of that in the bottom middle image there. Because they look so colorful, marine organisms and seabirds think it's food, think it's like small little plankton or small little fish, and they dive down and they eat a whole bunch of it. So as you can see there on that beach, it's filled with microplastics. And if a bird were to come by, he'd probably look at that and be like, ooh, buffet. But really, all of those microplastics don't do anything nutritional wise for that bird, so eventually they end up dying. Nurdles, which is depicted in the image on the left hand side there, are small little plastic pellets that are used to create plastic items. And so this is basically the beginnings of a plastic item. So a lot of other countries like China will create these nurdles, and then they will ship them around the world to wherever whoever needs them. And if something were to happen to that ship in the ocean, well, there you go. You've got a bunch of microplastics all of a sudden in the ocean. And that's what has happened on a number of occasions. All right, so where do you find plastics at? Plastics can be found everywhere in the ocean, but in particular in the subtropical gyres. So in this case, the Pacific Ocean has the North Pacific Gyre, right? That's flowing in a clockwise direction. And what it's doing is it's aggregating all of the trash that's getting into the ocean into two separate patches. One that's on the western side over by Japan, and the one that's over by the eastern side over by California. And as you can see, the one over by California is much larger. And it affects Hawaii because a lot of that trash from that garbage patch on the eastern side ends up coming to Hawaii eventually. So while trash will aggregate over there, it's basically creating its own gyre of trash. And so sometimes some of those trash pieces will get loose from the gyre, and they will circle around the Pacific gyre until they land on our shores. So here's just an image of just under the surface there of the garbage patch, and as you can see, it's pretty pervasive. There's a lot of rope, some fishing net. You can see some fishes running around because they think that it's a safe habitat, but in reality, those fishing net are doing ghost fishing, which we learned about in the last chapter. So it can be a hazard to live and make this your habitat, but you can see that there's a lot of stuff growing in there. And then here's just a top-down view, an aerial view of the garbage patch, and you can see it's pretty nasty. I mean, look, there's like giant boards, tons of plastic. I mean, you can't really see what's going on below the surface from this image, but basically whatever you see at the top, it goes down quite a ways. So, how do we fix the problem? The main thing to prevent plastics from getting into the ocean is by reducing the amount of single-use plastics that we use, as well as recycling our plastic and properly disposing of the plastic. So I would not say that disposing of the plastic into the garbage can is the proper way of disposing plastic, but here in Hawaii, really we don't have any other choice. Because majority of the plastics, as you can see in the image there's 7 different types of plastic, and only 2 of those are quote-unquote recycled here in Hawaii. Technically speaking, 1 and 2, so your PETE and your HDPE plastics are recycled here in Hawaii, but technically speaking, Hawaii does not do any recycling of plastic because we don't have a facility to recycle the plastic. What ends up happening is that plastic is then sold to a company, whether it be abroad or in the mainland, and they recycle it there. So we sell our quote-unquote recyclable plastic, but technically speaking, in the mainland, all of these plastics can be recycled. And a lot of places around the world, like Japan, recycles just about all of their trash. And then also too, there's places in the mainland that do a lot more recycling. For instance, like Oregon and Washington, they do significant amounts of recycling of their plastics. So single-use plastics are like your straws and your utensils, or for instance, that salmon you buy from Costco from the freezer section, each salmon fillet is individually wrapped, so that would be considered a single-use plastic. So that's plastic. So basically the lesson is recycle your plastic as much as you can. Try to use reusable utensils and reusable containers when you're eating out. Otherwise, plastic will continue to be a problem in the ocean. Next, we have thermal pollution. Thermal pollution is when you introduce hot water into the ocean. So a lot of times this occurs when you have like industrial companies near streams and oceans that use the ocean water to cool down their machinery. And when that happens, they take in the cool ocean water, run it through the machinery. It picks up the heat from the machinery, and then they release that water back into the ocean, but now it's hot. Okay, so that warm water that's going back into the ocean has a decreased ability of holding oxygen because it is warm, and you can have what you would call saline brines from desalination plants. So typically in the Middle East, where water is a limiting resource, they take water from the ocean, desalinate it, and produce fresh water. But when you desalinate ocean water, you're not getting rid of that salt, you're just extracting the salt. So when you do that, you have to have some place for the salt to go. So they typically will have huge holes in the ground just full of salt. Okay, so and then sometimes that salt can get back into the ocean if there's like a huge storm that occurs. So some things to note: the difference between threatened and endangered species, and pollution and human impacts have basically created these categories. And so a threatened organism has a population that are low in numbers. So it could still potentially come back to a non-threatened position if humans and other environmental factors were taken off of them. So, like for instance, the sea turtle is endangered, and it's primarily endangered because of the overhunting that occurred back in the day. But now that it's endangered and you're no longer able to hunt the turtle, the main cause for its inability to get out of the endangered status is pollution and climate change. So, turtles, what we're starting to notice is that the eggs, when they are buried in the sand, some of the eggs will end up in this pile and then covered with sand. And so some of the eggs will be on the outside touching the sand, some of them will be on the inside. And depending on how warm those eggs get, will determine whether the baby turtle will become a male or a female. So the warmer eggs, typically the ones that are found in the center, will turn into females, and the ones on the outside that tend to be cooler will turn into males. Well, what they're experiencing is with global warming and whatnot, you're seeing that majority of the eggs turn into females because it's warming up. So the amount of males that are being produced every year is decreasing. Okay, so endangered just means that they are immediate in danger of disappearing. So their numbers are extremely low, and if they are not protected, then they may disappear eventually. And then you have extinction, where you don't have any animals alive anymore from those species. So, for instance, the kiwi in New Zealand, that's a good example of an extinct or organism. You don't find them in the wild or in captivity at all. In this graphic here, you can see there's different levels at which organisms are either endangered or threatened or extinct in the wild, but you can still find them in zoos or aquariums or whatnot until you finally get to the point where they're just completely extinct. And back in the day, a majority of the extinct species were because humans hunted them to extinction. Another thing that can help the environment is by doing habitat restoration. So in this photo here, you can see they're planting trees in an area where either the trees were cut down or, well, I'm sure the trees were cut down from this area. But they're replanting them so that the carbon in the atmosphere can, instead of going into the ocean, get absorbed by the tree. So the tree is basically made out of carbon. And so instead of that carbon dioxide going into the ocean, it goes into the tree and forms the trunk and the branches and the leaves. And so that's what you would call a sink for carbon. So the ocean is also a sink for carbon, and it's a pretty massive one too. But the more trees we have, the less carbon that goes into the ocean and more carbon that stays locked on land. And this habitat restoration allows for the habitat to go back to what it previously was in the past. And then in the ocean, so that was on land, and in the ocean you can have artificial reefs, and this is where they place objects that help allow the reef to grow and allow habitats to form for other species like the fish. A lot of times the coral will not grow on sand, and so if you have too much sand within an area where there used to be coral, one way to get around it is to put down these large concrete blocks, which act as a habitat for that coral, like a stable, solid surface that it can grow off of. And so a lot of places will put these types of material down in the ocean to create more coral reef. All right, so that was chapter 18. Yep. 18. So that was the last chapter for the semester. Don't forget to do your homework, and don't forget your final exam and your note card for your final exam.